58,
Present, ma'am.
59,
Present, ma'am.
60,
Present, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64,
Present, ma'am.
65,
Present, ma'am.
66,
Present, ma'am.
67,
Present, ma'am.
68,
Present, ma'am.
69,
Present, ma'am.
70,
Present, ma'am.
Siley,
Present, ma'am.
Sakshi.
Present, ma'am.
Okay, fine. So we'll
Ma'am,
start now. Now we will take it later on after the lecture completes. Okay. So today we are going to start with exact differential equation. We have seen till now variable separable. What do you mean by variable separable differential equation? We have seen till now what do you mean by homogeneous differential equation and non-homogeneous differential equation. In variable separable also that were typed by substitution we converted to variable separable. That also we have done. And the types also were different. What Aditya has taken in flipped classroom, that is substitution of products, substitution of quotient, all those things. Okay. So now we go for the next type, that is exact differential equation. So what do we mean by exact differential equation? That we are going to see. Okay. So something should become exact means what? A differential equation will be given to you as it has to become equal to or it has to become exactly equal to some another function. And that what is that another function? Solution. So exact differential equation means will be what is the normal form or general form of differential equation of first order first degree? Who will tell me? First order first degree differential equation you can type it in the chat box also if you are not able to speak. I'll call out the roll number 25 from C division. What is the most general form of differential equation of first order first degree? M. Roll number 25 is present, na? C division. Yes or no? Put it in the chat box if you have, if your mic has any problem. Okay. Next, roll number 7, C division. What is the most general form of first order first degree differential equation? Roll number 7 is also not there. All those are not answers to be marked except that. Roll number 4.
Be ma'am, it would be mx comma y dx plus
This is roll number 7.
plus n
Yeah, m dx plus
plus
n
n
dy.
x comma y dy is equals to 0.
Very, yeah, good. mxy dx plus nxy dy is equal to 0. That is your this is your first order first degree differential equation. Yeah. So now this differential equation has said to be exact. This differential equation, when it will be said to be exact, is the condition or the definition goes like this. This should be equal to some equation on the left hand side or some function on the left hand side. What is this? This is a differential. What is the meaning of differential? Do you remember total derivative or total differential that we have done earlier? So that term was called something like du. Okay, and what is that u? U is a function in xy which may be equal to constant. So the definition of exact differential equation goes like this. The differential equation m dx plus n dy is equal to 0 is said to be exact if there exists a function u of x comma y is equal to c. if there exists a function u of x comma y is equal to c such that what is the thing? There exists a function u x comma y is equal to c such that m dx, that is mxy dx plus mxy dy is equal to d. This is the definition. I should be able to write, or I should be able to find a function in xy which is equal to constant d or some arbitrary constant such that the total derivative or total differential, derivative means with respect to. So this is called as total differential. The total differential of the function u is nothing but the given differential equations left hand side. Is the statement or the definition clear to everyone? Problem statement means what you have to understand what is the given problem. How to go about it to solve and all, that's the later stage. So first of all, is the definition clear to everyone? You know that any general first order first degree differential equation is of the type mxy dx plus mxy dy is equal to 0. This is your first order first degree differential equation. Okay? That will be said as exact differential equation if I am able to find a function u which is in terms of x and y equal to a constant. Constant of integration is there. This is the constant of integration because the order of the differential equation is 1. This function exists such that the total differential of the function u is nothing but your given left hand side mxy dx plus mxy dy. This is also called as total differential because it is written as total differential of u. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. So that is the meaning of total
Miss,
differential is u and yeah.
आमचं एम आणि एन काय आहे म्हणजे
Loudly. I can't hear you.
मॅम ते एम आणि एन कळालं नाही काय
You were not there for any of the earlier lecture. This definition we have started from the first lecture. What is the meaning? Mxy, it's a function in xy. Any differential equation of first order first degree. That means you are not doing the beginning of this lecture. Mxy is a function in x and y. Nxy is a function in xy. Any differential equation is of order first and degree first. Can be written in this form. Dy by dx is equal to function upon function. Or mxy dx plus nxy dy is equal to 0. This is the most general form of first order first degree differential equation. Is this okay?
पण ते
Who has
माहिती
asked
नाही
this question?
चैतन्य
Okay, so you are not Chaitanya, you are not present for the earlier lecture classes. So mxy dx plus mxy dy is equal to 0. That is your first order first degree differential equation. Okay, and any this mxy means it should be any function of xy. We can have constant also, and xy means also a function in xy which can have constant. Okay, so this will be said to be exact if I can find a function u which will be having its total differential equal to the left hand side of the given question. Okay, now the question starts how to find that u. So that is the solution part of the differential equation. Okay, so for that we have to revise or repeat what we have done in n1. Suppose uxy is equal to c is a function in xy. Okay, then what is total differential of u? You remember we did this in partial derivative. U is depending on x and y. Then the total differential, total derivative will be du by dx. But what is total differential? Just change u. With respect to both you have to change. So what was that total differential formula? Who can tell me?
Ma'am, is it del by u by del by x into del by x dx?
Yes. Del by u by del by x into dx plus del by u
Del
by
by u by del by
y
into
into
dy.
Excellent. Excellent. That's the thing. Now somebody, Anjali is asking me the question. Does this form indirectly means that for a particular differential equation, there will always exist only unique solution to it. You will get a unique solution. Obviously, by this method, you may not get all the solutions. Are you getting it? But obviously, unique solutions in the sense, if you're talking about general solution, it will change if they help on that arbitrary constant. But other than that, when you take a fixed value c, it will become a unique solution. So you should be getting this function u of x comma y. Okay, that function will define the solution, but for which mxy dx plus mxy dy equal to 0 should be an exact differential equation. Then I am able to find this function u. Or if you are able to find the function u, then it will be exact. So we'll be able to find the solution. Right? This is one particular way. The other ways were what? If it was variable separable, we just integrated it. No? Is the question answered, Anjali? Yeah. Okay. Okay. So, and this question is very important, okay, because this question was asked in one of the interview also, that is every differential equation exact? If every differential equation was exact, then why there was a need for solving variable separable differential equation, homogeneous? Again, there is another thing that once this is exact, we are going to solve it in one way. There are examples which are not exact. So how we would have gone for those type of questions then? So definitely, some differential equation which fall into the category of exact differential equation will be solved by this method. There are other methods, first order, first degree, whatever we are going to study in M2. Other than that, also there are some other methods which will be used to solve the differential equation. Those are numerical methods. Like there are Euler's method for finding the approximate solution with boundary conditions. Then there is Runge-Kutta method for finding the solution of a differential equation, which you are going to do it in M2. Okay, you are under the subtopic of numerical methods. Right now, we are solving the preliminary methods of first order, first degree differential equation. So yes, the students who told that if uxy is equal to c is a function, then the total differential, this is called as total differential of u is nothing but del by u by del by x dx plus del by u by del by dy. Okay, up till this everyone, is it clear? This is your question. If there is a question, if there is a function uxy is equal to c, then what is du? Du is del by u by del by x dx plus del by u by del by dy is equal to 0 because the derivative of constant is 0. Clear? Everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay. So yes. So now what we will do? How do we identify that whether it is exact? Yes. Very good. This is the way. Again, you are coming back to the normal track now. You are thinking, how do we come to that? How do we identify whether it is? So that is called as necessary condition. We will come to that. That's why we will this. Now the next step is compare this two. I'm taking time for you all to understand this because if you once understand this, then you'll be able to understand everywhere where you can apply. Okay. Now can you compare the two? Equation 1 and equation 2. Can you compare?
Del by u by del by x is equal to
mxy
mxy. And del by
Very
u
good.
by
Very
del by
good.
y is equal to
Yes.
equal to
mxy.
mxy.
And absolutely right. Very good. Very good. That's what I wanted you all to go to the next step. So if I have to compare this to the function u is such that m is nothing but del by u by del by x and n is nothing but del by u by del by y. Is it okay? This is called as equation 3. This is called as equation 4. Equation 3 and equation 4. Now I am taking the derivatives. I am taking the derivatives of this function. That means it should be continuous at least. Yes or no?
Yes.
Do you remember
Yes,
this
ma'am.
concept which we had done? Yeah. Yeah. So if I suppose now differentiate m with respect to y, what is derivative of m with respect to y? This is your m. You have to differentiate this with respect to y, so it will become deva square u by
Deba square
deva
by
by
deba
x.
y deba x.
By x.
Very understood? Understood clearly? Okay. What will be deva m by deva x?
Deva square u
Deba
by
square u
Deva square u by
deba x deba y.
okay. Yes, yes. So now this function m and n are differentiable. We got the value of deva m by deva y, deva m by deva x. So what is the relation between these two?
Equal.
Absolutely right. So then are you remembering all of y'all that if the function is continuous,
Ma'am.
then this mixed derivative should be equal, which we have done in partial differentiation, unit 5, unit 3, I suppose, unit 3 of M1. So these two partial derivatives should be equal.
Yes, ma'am.
Yes, ma'am.
Necessarily, there should be the sense of taking the derivatives.
Yes.
Correct? Therefore, the necessary condition for the differential equation to be exact is delta m by delta y should be equal to delta m by delta x. Okay, so identifying that there exists an u and then saying it is exact will be a very lengthy process. Okay, but you know the question m dx plus n dy is equal to 0. So you know what is m, you know what is n. Finding delta m by delta y and delta m by delta x is quite easy. So once you take these two derivatives and if they are equal, you will see that the differential equation is definitely exact. This is the necessary condition. And to prove that it is exact, you find that u. So that is the solution. I think the derivatives of the function should be continuous. Derivative of the functions, no. What, when do we say that the mixed partial derivatives are equal? We have done that if the function is continuous and the first derivatives, partial derivatives are existing, okay, and they are in x and y, then obviously the second mixed order partial derivatives will be equal. We have seen that all the examples we saw in partial differentiation. Is that okay, Babu?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. So delta m by delta y is equal to delta m by delta x is the necessary condition for the differential equation to be exact. And once that is satisfied, then we go to find what is the solution of the differential equation. So up till this, everything is clear to everyone. Your question is given as to be nxy dx plus nxy dy equal to 0. By definition, it is said to be exact if there is a function uxy equal to c, which says that total differential of the function u is nothing but the value of the left hand side of given question. Now, if such a question exists, then total differential of u is this. So by comparing the two, delta u by delta x is nxy, delta u by delta y is nxy. And for the derivatives, discontinuous derivatives, mixed product derivatives, they are equal if the functions which are the derivatives we are taking, they are continuous, as well as the functions are continuous. Then we can talk about, because they will be polynomial form, so then we can talk about the mixed derivatives, they will be equal, and that is delta m by delta y should be equal to delta m by delta x becomes the necessary condition for the differential equation to be exact. Okay, so you write down these things quickly, please. A differential equation mxy dx plus the differential equation mxy dx plus nxy dy equal to 0. mxy dx plus nxy dy equal to 0 is said to be exact differential equation. Is said to be exact differential equation. Exact differential equation. If there exists a function ux comma y is equal to c, if there exists a function ux comma y is equal to c, ux comma y is equal to c, there exists a function ux comma y is equal to c, such that mxy dx plus nxy dy is equal to d. mxy dx plus nxy dy is equal to d, where du is the total differential of the function u. Du is the total differential of the function u. That is, if ux comma y is equal to c, if ux comma y is equal to c is a function, ux comma y is equal to c is a function, then total differential du is equal to delta u by delta x dx, delta u by delta x dx plus delta u by delta y dy, delta u by delta y dy is equal to 0. Is equal to 0. Comparing 1 and 2, delta u by delta x is equal to mxy, or mxy is equal to delta u by delta x, mxy is equal to delta u by delta x, and nxy is equal to delta u by delta y. nxy is equal to delta u by delta y. The total differential, the differential of u, the differential of u is a function in xy is a function in xy. So the mixed partial derivative continuous function in xy, continuous function in xy. The mixed partial derivatives of u mixed partial derivative of u should be equal, should be necessarily equal, should be necessarily equal, necessarily equal. That is delta n by delta y, delta n by delta y is equal to delta n by delta y is equal to delta square u by delta y delta x, delta square u by delta y delta x is equal to delta square u by delta x delta y, delta square u by delta x delta y, which is equal to delta n by delta x, which is equal to delta n by delta x. Therefore, the necessary condition, yes, Kaustubh, you have any doubt?
No, madam.
Therefore, the necessary condition for equation 1 to be exact, is delta n by delta y is equal to delta n by delta x. Delta n by delta y is equal to delta n by delta x. So if this necessary condition is not satisfied, that means they are different. How we are going to use it in the examples? If delta n by delta y is not equal to delta n by delta x, then the differential equation is not exact. Therefore, this is not the method. Whatever we are going to see now, that's not the method to solve it. Okay, we'll see the other methods for that. But if delta n by delta y is equal to delta n by delta x, then the differential equation will be exact, and we will find the solution by that particular method. So now let's go and see how do we get the solution. Okay. So let me generalize it first, and then because if I tell you the method of finding the solution directly, you will be getting mixed up. Let's see now. From equation 3, delta u by delta x, what we have there? Partial derivative. That means you have to do, if I want to get the value of u, I should do partial integration. Do you agree with me? All of you. Those who can't speak can say yes in the chat box. Those who can speak can say directly yes. So nxy, which is du by dx, delta u by delta x. If I want to get the value of u there, I should integrate that three equation partially with respect to x. Correct? So partially मुझे integrate कैसे करना? How we are going to do? Let's say integrate equation 3 partially with respect to x. So what will be delta u by delta x? It will become u delta by delta x integration delta x. While writing here, I am writing it as delta x. Actually, it can be said to be because I am doing partial means y is constant. Okay, is equal to integration of mxy dx. Here y is constant. What is the meaning of partial? Partial integration or partial differentiation? That means you have to take y as constant. If I am differentiating with respect to x, y should be taken as constant. Along with that, there will be constant of integration. Yeah.
Ma'am, can you please repeat why we are integrating it?
Yes. we want to find now that function u. Who is that function u? So we are going to the solution ना. So what? How will you get the solution? Differential equation का solution मतलब क्या? Relation between x and y. So when I have written m dx plus n dy is equal to 3. Okay. So this is also derivative. This is also derivative. So how will you get the solution? By integrating that.
Yes, ma'am. Yeah.
So what integration when you are going to do dx के साथ यहाँ n में x और y भी है. So how you are going to do that? And here with dy n also has x and y. So दोनों जगह पे you always need to take y is constant. Whenever you are doing integration with respect to x, you will say y constant, and integration with respect to y then x constant. Then it will become fixed. The solution will be a fixed type. Are you getting it? So how do we come to that conclusion? You have to take constant. What else you do? That I am telling you. So कोई भी differential equation, any differential equation you want to solve it means you have to find the relation of y and x, remove the derivatives and get into picture that will be constant. Isn't it? That's the meaning of solution, no?
Yeah.
Okay. That's why I do integration. So integration is not directly I don't know how to do. And that's why I'm making use of this equation which we have written with the help of the total derivative of u, total differential of u. I try to integrate this and get the solution. Is it clear to everyone? Good question that she asked.
Yes, ma'am. Okay.
Okay, fine. So now I know that since I'm doing partial integration, I'm doing the integration with respect to x, that time y will be constant. Clear?
Yes, ma'am.
Yes? Okay. Yeah. So here, when I'm doing the integration, this is not definite integration, so our constant of integration will come. Yes or no?
Yes, ma'am.
So if constant of integration is there, in this constant, what possibilities are there? That's the most important thing that we understand. We have to actually write down the entire solution. In that C, what possibilities are there? Can it be a function of x? Are you getting it? What I'm trying to ask you? Can it be a function of x? C. C is a constant.
Yeah.
If C can have x, that means at that part of actually a constant x कैसे आएगा? Cannot have x.
C cannot be
Constant C.
No, ma'am.
C cannot be x.
This cannot be.
Okay, very good. C cannot. It cannot be function of x. Can it be function of y?
No.
Yes, ma'am.
No.
No, ma'am.
No, it
Ma'am.
can't.
All are saying no.
Yes, ma'am. We are taking
It can be.
All are saying no.
It can be.
Look here.
It can be a function.
What is written? Very good.
y is equals to
You have written
constant.
that integration with respect to x, that time y is constant. So this C can have y. Because that time when I'm doing the integration partially, y is a constant. So this C is a function of y, which can be constant also. Are you getting it?
Yes.
G of y can be a function of y or it can be constant. Or it can be constant. Okay?
Yes.
Yes, ma'am.
So now to find this g bar with the help of n is a lengthy process. Okay? Again, you have to do this is g of y. Na? So what you have to do? You have to differentiate this with respect to y and then get the answer. So it becomes a bit lengthy, which is there in your reference book that is given up. Now I tell you the short way of doing it with the help of directly or differential equation. Just see this. We have m dx plus m dy is equal to 0. I have done the integration of m with respect to x, y and I have taken y as constant. This g of y we are going to get with the help of n. This g of y I am going to get with the help of n. तो वहाँ पे सिर्फ वो y का फंक्शन हो सकता है या फिर कांस्टेंट हो सकता है. It cannot be a function in x. So what will be the thing? How will you get it from here? यहाँ से मुझे सिर्फ समझ में आ रहा है how I am relating?
No, ma'am.
Yes or no? Let's see. I'll write it first and then I'll ask you. Okay. So what will this say now? U of x comma y is equal to integration mx comma y dx, where y is constant. Okay. Y is constant. Plus this g of y, I'll do as integration mx y dy. Okay. Is equal to c आएगा. ठीक है. यहाँ पे I say the terms free from x. n will have some terms in x, remove those terms, only what will remain? Y terms will remain. And that integration which we will do, we get this g of y. Are you getting it? अभी समझ में आया? How I get the relation? Okay, the process which goes behind finding this gy is quite lengthy. If we go by again differentiate this, then integrate it, so it will have integration and differentiation under integral sign. So it becomes lengthy. That's why I'm directly relating the two and getting the answer. Here the g of y चाहिए. I want this to be only function of either y or x. So this n can be used to solve that, and for that I have to remove all the terms which are in x in n and then do the integration. Is that clear?
Yes.
So what do you mean by terms free from x? Whatever this x, suppose your nxy is say x square plus xy plus y cube. This is your n. So which are the terms like x square, xy? So remove these two terms and only do the integration of y cube, you get that y plus arbitrary constant c. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
एवरीवन ये समझ में आया ना, तो आपको फिर से वो ध्यान में रखना नहीं पड़ेगा कि these are the type of solution which can be given for exact differential equation. I'll repeat once.
मैम एक बार और
Yeah. M dx plus n dy is said to be a differential equation exact if it is equal to du. With the help of that, we got that total differential of du is nothing but, I'll write it here, it is delta u by delta x into dx plus delta u by delta y into dy. Comparing this two, I got that m is nothing but delta u by delta x, n is nothing but delta u by delta x. Okay? Now to find that u, this derivative has to be removed. Delta u by delta x जो है वो remove करके सिर्फ u चाहिए. So I have to do integration. लेकिन यहाँ partial derivative है, so partial integration should be done. So I have done the integration partial. What do you mean by partial integration? जैसे partial derivatives are same here partial integration है. So whenever I am doing integration with respect to x partially, y has to be taken as constant. So I have done that on both sides. So you can write here also, y is taken as constant. So integration mx dx, y is constant plus the constant of integration. That constant of integration can be function of y because your y is a constant vector. So now you have to find how will I get this g of y. So compare now the original question with this. So uxy integration के बाद du का integration uxy आएगा. यहाँ पे integration already है, तो सिर्फ ये n dy बचता है. So I get this g of y with the help of n, which is nothing but there is no x term here, so n xy dy is a terms free from x के और उसका integration करो with respect to y. That will be g of y. Along with that, you will also get the function of integration. And therefore, your general solution for exact differential equation is nothing but the function uxy, which is equal to c, is our answer, which is actually obtained by integrating mxy dx, taking y as constant, plus integration mxy dy, terms free from x, you remove the terms of x from n, is equal to c. Is it okay? Is this clear now?
Yes, ma'am. And
Everyone?
even x can be taken
Yes,
as
ma'am.
constant, na?
Absolutely right. If you have understood this, that should be the very next question that you are asking. Is this anything special about taking n partially integration with respect to x करने का कुछ speciality है क्या? नहीं. We can start with partially integrating with respect to y also, na?
Y also, yes.
Correct? Yes or no?
Yes, ma'am.
All of you, please listen. So if you have understood this, tell me if I start with n first, partially integrating with respect to n, then what will be the solution? Integration.
And
बताओ.
m of xy
n
F
y
dy
dx
dy.
x
n के साथ dy है. x is
x constant
constant plus
plus m of xy dx
m of
x
x y
dx
terms free from Y.
near y is constant.
free
very
from y.
good. Terms free
Free
from
from y.
is equal to c. That's your answer. So these two are possible solutions. Is it okay? दोनों constant हो नहीं सकता, दोनों में free हो नहीं सकता. क्यों? That I told you. This is the reason. Is this okay? This question, when you if I tell directly this solution, ना ये solution अगर मैंने directly बोल दिया, then the students get confused कि y constant x constant दोनों क्यों नहीं आ सकते, term free from x term free from y दोनों क्यों नहीं आ सकते? Are you getting it? So that is not possible because of this partial integration which we do. Is it okay? Because when I do partial integration, this should be only function of y. If I do partial integration, this should be only function of x. So terms free from x करने ही है. Terms free from x या फिर terms free from y. Any one of them you do. Any one. And if you are taking terms free from x, y should be constant. If you are taking terms free from y, x should be constant. Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. One more thing, many students have doubt. Can you ask? Can you tell me that what will be the thing? This is not a problem in very the ones who have understood clearly, but still जो थोड़े average में रहते हैं, dilemma में रहते हैं, उसमें उनको और एक problem आता है. dx के साथ यहाँ पे x constant लिख देते हैं, and dy you write terms free from y. Can that happen? You want to do integration with respect to y, and if you are saying terms free from y, then you are not doing anything. X का क्या करोगे फिर? समझ में आ रहा है?
Yes.
Everyone, please be careful about this. If you are integrating with respect to x, you have to think what to do about y. अगर आप integration with respect to x कर रहे हैं, तो आपको पता है x का integration क्या होता है, या फिर x square का, या sin x का, cos x का, you know that. But if you are having y term, then what I have to do about y? So either you have to take y as constant or you have to take terms free from y. Is it clear?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes. And when you are doing integration with respect to y, आपको normally या फिर common sense से x का क्या करना है? This question should happen. Then again, either you can free the terms from x or take x is constant. Is it okay? So what are the combination? Either mx dx y is constant or terms free from y or
X is constant.
x is constant. These are your two possible solutions. Is that okay? Not the other, no other possibility, no other combination. Y constant है तो वहाँ पे terms free from x होगी, यहाँ पे terms free from y लिए तो x is constant. Okay? So you please already it's time of your next lecture must be starting. So we'll stop here. I'll share the notes of this. Please complete this writing the solution. I'll ask tomorrow. Fine? I've already taken the attendance. So we'll stop. We'll revise once again tomorrow, and I'll ask you all. So please see to it that you what you do.
Ma'am,
You understand this and write it properly. Yeah.
मॅम ते 4 वाजता गॅदरिंग होतं ना ऑनलाईन.
एक second. Let me stop the recording. Then we'll discuss that.